All right, so as promised, this video is going to talk about more complex ratio tables. And these ones are more complex because you can't exactly see what we're counting by, and the pattern isn't obvious. So like, for example, for this one, frogs to toads, this is 4/6. The next number is not going to be 12. This is not going to be 12. And that's because on the top, you can tell that we're obviously not just counting by fours. So because we're not just counting by fours, I have to figure out the pattern that's happening. So this is when pattern searching is important. Look for the patterns. Okay. So what I'm going to do is I know that the top, all of the frogs, have to be proportional. So I have to find it in groups of something from the previous one. Okay. So I know that if there are 4 frogs, I can get from 4 to 20. I know that I can count by fours to get to 20. How many groups of 4 get me to 20? 5 groups of 4. So if I do 4 times 5, I can get 20. Okay. Now because I took the 4 from this first ratio, I have to take the number from the first ratio to get this bottom number also. So to get from 6 to this one, I have to also multiply by 5 because 5 is what I multiply by. So this is 6 times 5. 6 times 5 is 30. So this new ratio is 20/30. Okay, now again, I know that it's a little bit complex, but here's what I did again. I took the frog number in the first ratio, and I saw that there was a pattern to get to 20. I know that 4 times 5 is 20, which means I can take the denominator, or the bottom number, the toads, and also multiply it by 5 to get to the number that should go there. Because in ratio tables, everything is proportional. Each number comes from the previous one somehow. Okay, you just have to find that pattern. All right. Now the next one is a little more tricky. I don't know exactly how many groups of 6 get to 90. But I do know one thing. I know how many groups of 30 get to 90. So I can go from this second ratio that I've created, 20/30. I can go from 30 to 90. Now, how many groups of 30 get to 90? If I take 30 and I multiply it by 3, then I know that I get to 90. Okay. All right, 30 times 3 is 90. So I took 30 from this ratio and I multiplied it by 3. So 3 is the number I'm multiplying by. So I take the 20 from the same ratio, and this time I do 20 times 3. Okay. Again, times 3 because 3 is what I multiplied by on the bottom. And 20 times 3 is 60. Yay. So these should be equivalent ratios also. Because again, I took the two numerator and denominator from the same ratio and I multiplied them by the same number. This is like if I took 20/30 and I multiplied by 3 and then I multiplied by 3 and then I would have gotten 60/90. Do you see how this is like equivalent fractions, like what we've done in the past? Okay, so now let's do this last one, 180. Well, I can get to 180 from any of these numbers, 6, 30, or 90. But I know that 90 is quicker because 90 is bigger and it's closer to 180. If you chose to go by 30s, that's okay too. But I do know from 90, I can get to 180. 90 times what equals 180? Well, 90 times 2. 90 times 2. 90 times 2 is 180. And I'll check it over here just to make sure. 90 times 2. 2 times 0 is 0. 2 times 9 is 18. 180. Perfect. Okay. So then on the top, I can do the exact same thing from the same original ratio. So from the 60/90. This time I take 60, and I need to multiply it by the same thing I multiplied by on the bottom. So this becomes 60 times 2, which is 120. Okay. And I've filled out my equivalent ratios. So now what I can do is I can check each of these ratios to make sure that they're equivalent. I have 4/6. That's the first one. I have 20/30. That's the second one. I have 60/90. That's the third one. And I have 120/180. Now I can check these by using the